Hello students and welcome to part 2 of Unit 3, Lesson 3. In this part of the video we will do one multi-step example and then we will summarize what we've learned. Here's our problem. A water tank like the one to the right, here pictured, is used to water flowers at a park. Water can be pumped from the tank at a rate of 25 liters per minute. How long will it take to use all of the water in a full tank? Round to the nearest minute. Now let's get a game plan for this multi-step example because it takes many parts to complete. It wants to know how long it will take to use all the water in a full tank. Well, so our first step is going to be able to figure out how much water is a full tank. Now, if you look at the picture, you can see that it is all in meters. We know that 1 liter is cubic centimeters. So when we solve this problem, we're going to have to switch these to centimeters so that we have the right units. So when we figure out the full tank, it's going to be in cubic centimeters. Our second step is we're going to have to figure out what the full tank is in liters, knowing that 1 liter is 1,000 cubic centimeters. And then our last step is if the water leaves at 25 liters per minute, how long till it's empty? When you are solving multi-step or complex problems, it is really key to know what you're looking for and develop this game plan on how you're going to get there. So our first step is we are going to figure out how much water can be held in this tank. Now, if you look at the tank, does it match one picture on your formula sheet? And the answer is no. This tank is made up of 2 compartments, a cylinder and a cone. The top is a cone. Okay. Now, that means that we're going to have to find the volume of each and then put them together in order to calculate the area or the volume of the full tank. So look up how you find the volume of a cylinder, which is pi times the radius squared times height. Now, if you look, it says that the height of the cone is 0.25 meter or a quarter of a meter. We know that there are 100 centimeters in a meter, so that's 25 meters. It's telling us that the radius is 1.5 meters, so that'd be 100 for the whole meter and 50 for the half a meter, so that's 150 centimeters. And it's telling us that the height is half a meter, so that's 50 centimeters. Now that we've converted them all to centimeters, we can substitute for our radius and our height. Now notice we're only talking about the cylinder, so this piece of information at the time is extra information. The radius is 150, so we'll have pi, which is 3.14, times 150 squared times the height, which is 50. We must start with exponents, so 150 times 150 is 22,500. So we have 3.14 times 22,500 times 50. So if we multiply that, 3.14 times 22,500 is 70,650 times 50, and we get a total volume of 3,532,500 cubic centimeters. Now remember, a cubic centimeter is probably only the volume of the end of your pointer finger. Now our next step is we need to figure out the volume of this top portion, which is a cone. Look on your formula sheet and figure out how you figure out the volume of a cone. And you will see that it says 1/3 pi r squared height. Now, if you look at the cone, we can see that it has the same radius as the cylinder, which is 150 centimeters. So we'll have 1/3 times 3.14 times 150 squared times the height, and just take the height of that cone, which is 25 centimeters. Now, we see multiplication, multiplication, exponent multiplication. We have to do exponent next. So we have 1/3 times 3.14 times 150 squared, which we already figured out to be 22,500 times 25. Now, since all of our expressions multiplication, we can do it in any order. So we'll save the fraction for last. So we'll do 3.14 times 22,500 times 25. So we have 3.14 times 22,500 times, that's 3.14 times 22,500, which is 70,650, times 25, which is 1,766,250. And remember, we still need to multiply that by 1/3. Now remember, this has a denominator of 1. So when we multiply straight across, we get 1,766,250 divided by 3. So when we divide that by 3, we get 588,750 cubic centimeters. Now, that is just the volume of the cone. And here we have the volume of the cylinder. So if we want to know how much for the full tank, we have to add those two amounts together. So we have 3,532,500 plus 588,750, which gives us a total of 4,122,250. So now we know the size of the full tank. So I'm just going to erase this to give us some more room. Which was our first step in solving this problem. So as I just said, we've now figured out that our full tank is 4,121,250 cubic centimeters. Now, we need to figure out how many liters that is. Now remember, it takes 1,000 cubic centimeters to make 1 liter. So the amount of liters is going to be a smaller number than the amount of cubic centimeters. So that means we're going to have to divide by 1,000 to see how many liters. So the full tank is equal to 4,121 and a quarter, which is 0.25 liters. Now our last step is, if we pump the tank at a rate of 25 liters per minute, how long will it take for all the water to go out? So if we divide the tank into sets of 25, which would each be a minute, we get 164.85 minutes. Now, if you know anything about time, you know that there's 60 minutes in an hour. So if we take away 120 minutes, that would be how many hours? 2 hours. So we could also say that this would be 2 hours, 44.85 minutes, which means almost 45 minutes. So if you are in advertising, you could advertise this tank to last 2 hours and 45 minutes when full. Now let's summarize what we've learned. Substitution is to replace a variable with an equivalent value, often a constant. When we are solving formula-based questions such as volume questions, we can substitute values we know in order to solve the formula. When we solve a formula, we are really solving an expression using the order of operations. And please remember, every shape has a different formula for volume and area, so use those formula sheets.